Hey, one of my favorite lessons in this textbook is about arithmetic sequences, and later on in the year we'll look at geometric sequences. But for now, we're talking about numbers generated that fall into a certain pattern. That pattern being this. We're going to add the same number each time to generate the new number. Sounds pretty simple, right? So if I said to you 1, 3, 5, 7, you would say, well, that's an arithmetic sequence because each time we're adding 2. Our objective for the lesson today is to recognize and extend an arithmetic sequence, meaning add on to it given the pattern that we've recognized. We're going to find a given term of an arithmetic sequence. If I said to you 1, 3, 5, that's the first 3 terms. And if I asked you to find the 100th term, you can do that quickly and painlessly with our new formula we're going to learn today. Key vocabulary terms are sequence, term, arithmetic sequence, and common difference. Let's consider this situation. During a thunderstorm, you can estimate your distance from a lightning strike by counting the number of seconds from the time you see the lightning until you hear the thunder. When you list the times and distances in order, each list forms a sequence. A sequence is a list of numbers that often forms a pattern. Each number in a sequence is a term. Let's look at this. We're talking about lightning and thunder again. The time in seconds is 1. The distance is 2/10 of a mile. For every increase in 1 second, we increase by 2/10 of a mile. I know what you guys are thinking. You're thinking, this is a linear function. I know, because the changes in x are constant and the changes in y are constant. Well, we're talking about these numbers being generated. This is what we refer to as an arithmetic sequence. 2/10 greater each time when the terms of a sequence differ by the same non-zero number, d. The sequence is arithmetic, and d is the common difference. The distances in the table form an arithmetic sequence with a common difference of 2/10. The variable a is often used to represent terms in a sequence. The variable a sub 9, read a sub 9, a with a little 9, is the 9th term in a sequence. To designate any term, or the nth term, you write a sub n. N can be any number, and we're used to that because we're in algebra, and we know that variables happen. To find a term in an arithmetic sequence, add d to the previous term. Hence our first formula. The formula makes a lot of sense, but it doesn't seem like something you'd use. We know that we just have to add d each time we want to find a new term. Let's look at this equation, though. This says any term, a sub n, is found by taking a sub n minus 1. All that means is the term before a sub n, we're taking 1. So if this is a sub 10, this is just a sub 10 minus 1, which is a sub 9, the term before the 10th term. We take that term, we add a difference to it, and we get the next term. Determine whether this sequence appears to be arithmetic. If so, find the common difference and the next 3 terms. We do that by finding the difference between successive terms, meaning this one to this one. Is that the same as this difference to that one? So we calculate each of those. 9, 13, 17, and 21. We see a difference of 4, 4, 4, and 4. Well, too many 4s, but you know what I meant. And then it says, find the common difference. We need the next 3 terms. All we need to do is add 4 again. 21 plus 4. 25 plus 4. 29 plus 4. Gives us the next 3 terms. We just successively added 4. Here's the formula. Take the 4th term, add the common difference to find the fifth term. To find the sixth term, take the fifth term and add the common difference. Seems pretty easy. The three dots at the end of a sequence are called an ellipsis. They mean that the sequence continues and can read as, and so on, and so on. Example 1b says, determine whether the sequence appears to be an arithmetic sequence. If so, find the common difference. Well, differences can be negative as well. Let's look at the differences between these four terms. We can see between 10 and 8, we have a -2. 8 and 5 is -3. 5 and 1 is -4. We do not have an arithmetic sequence. Successive differences are not the same. Therefore, we can't use our formula on it. Let's try check it out. 1a, determine whether the sequence appears to be an arithmetic sequence. If so, find the common difference. Well, the good news here is the denominator is always 4. So let's just deal with the numerator. -3 to -1. -1 to 1 and 1 to 3. We can see each time that we're adding 2/4, which is exactly the same as 1/2. Therefore, it is an arithmetic sequence. Let's look at check it out 1a a little bit further. Use the common difference to find the next three terms. We're going to take the fourth term to find the fifth term. We're going to add to it 1/2. 1/2 is the same as 2/4. So we'd say 3/4 plus 2/4 is 5/4. 5/4 plus 2/4 is 7/4. And 7 plus 2/4 is 9/4. Finding the next three terms given the difference. Let's look at this one. Does it appear to be arithmetic? Adding 2, 3, and 4? No. There is no common difference. Therefore, it is not arithmetic. To find any term in a sequence, we're going to look at a brand new formula. It says to find the nth term of an arithmetic sequence when n is a large number, meaning the number of term we're looking for, you need an equation or rule. Look for a pattern to find a rule. Here is our sequence, our arithmetic sequence. This is the number of the term it is. This is the position in the sequence that it holds. We're going to go 1, 2, 3, 4, all the way up to n. The term a sub n is the one we're looking for. Here's how we can think of this. The sequence starts with 3. The common difference is add 2. You can use the first term and the common difference to write a rule for the nth term. Let's look at this. First term. How do we find the second term? We added 1 difference to it. How do we find the third term? We took the first term and we added 2 differences to it. How do we find the fourth term? We take the first term and we add 1, 2, 3 differences to it. Our common difference times n minus 1 plus the original term. Hence, we can conclude our formula. Take the first term and add n minus 1 differences. That'll give you the nth term. Let's see how that looks. The pattern in the table shows that to find the nth term, add the first term to the product of n minus 1 and the common difference. Please write this down in your notes. Make sure that you have it. And you should, while you write this formula, define what each of these means. A sub n just means any term. A sub 1 means first term. N means the number of term we're looking for. And D is our common difference. Let's find the nth term of this arithmetic sequence. We have 4, 8, 12, and 16. We want to find the 16th term. But I don't just want to add 4 12 more times. I want to use my formula. So let's find our common difference, which is positive 4. Write the rule to find the 16th term. We know that a sub 16 is the first term plus 16, we're finding the 16th term, 16 minus 1 times our difference. Substitute 4 for a sub 1, since that's our first term, 16 for the number of term we're looking for, and 4 for the difference. Now it's simple computation. Parentheses first, 16 minus 1, times 4, 15 times 4, plus 4, gives us our final term, or our 16th term, 64. Easy, easy. The 16th term is 64. Example 2b, it says find the nth term. We want to find the 25th term. We're given the first term, and we're given the difference. We don't have a sequence now. We don't have to figure anything out. All of our players are set up for us. We're going to find the nth term. N happens to be 25. We're going to substitute -5 for a sub 1. It's our first term. We're going to substitute -2 for D and do our calculations. Our 25th term, remember, parentheses first and then multiply and then add, is -53. Please look on PowerSchool for your assignment, and we'll see you tomorrow.